All right, I'm super welcome to see everybody. Thanks for coming to the talk. I'm super excited to share GPT-OSS with you. So I'm going to talk about something we did this year in August. Okay, so we released this model where in addition to completing text, we released this format called Harmony that lets you first specify a system message, give it all your tools, and have a set of channels which are going to participate in the response. So after you give it a tool list and a system message and a user message, it conditions itself on this chain of thought. And after it conditions on chain of thought, it produces the answer. So this is the first reasoning model that we released at OpenAI after releasing O1, an O3, and O3 Mini. Okay, so I'm really happy to share this GPT-OSS work with you guys. We released this model early in August this year. This is our first open source release is GPT-2, so I'm pretty excited. Are we doing good? Yeah, okay. Awesome. Oh, we're making up screen space. Okay, this is I'm talking, which is true. Okay, so since GPT-2, which was a text completion model, trained on a lot of text from the internet, this one has training in this special format we call Harmony. It had these special tokens, and some of them specify what channel the output goes to. So this is compatible with the work on like instruction hierarchy. There's a hierarchical dependencies between things and the prompt. We give it a system prompt. We give it a condition on the reasoning level. We give it potentially a list of tools that would show up after a reasoning level. You could put your Python, your browser, your weather app, your Mac app tool, and all of these kind of interesting things that can give you perception abilities and coding abilities and execution abilities. You give it a prompt with your question, and then it conditions itself on this chain of thought. This chain of thought differs in length. You can specify reasoning efforts of low, medium, or high, and depending on the one that you choose, the reasoning effort will become longer and longer. So you can ask the network to perform more or less thinking about your prompt. And after this, it conditions its own answer on the chain of thought. So these conversations can grow all the way from like 20 tokens to 100,000 tokens, like over 100,000 tokens. So this model is great for writing code. On Codeforces, our largest model with tools gives 2,600 Codeforces ELO rating, which is better than I do for sure. It does really good at using your tools. So we definitely wanted to give you the ability to interact with the external world. It also does really good at searching the web. We train it on this browsing tool. The browsing tool lets us access things from the internet and uses it to solve tasks like Humanity Last Exam. And without tools, it does really well on this Google-proof question answering task, which is like an ABCD task where you have to give a science question and the potential answer to find the correct answer letter. So since GPT-2, we made a few changes to the architecture, but we tried not to make it too crazy. So one is we increased the vocabulary size to 200,000 tokens. It's the vocabulary called O200K Harmony. Harmony is for the format, for specifying all the tokens that delimit channels. We have an interleaving attention layer structure, where first every odd layer attends only to 128 recent keys, so you can save almost half of your memory. And all even layers attend to everything up to 100, or over than 100,000 tokens. We have 64 attention heads. They're partitioned into 8 key value groups, and each has 64 dimensions, which is great for your computers. And our attention has a sink where we learn a bias for the denominator so your activations don't become too large. So you can, like, for example, if you like quantization, you can do this. And we switched from learned absolute positional embeddings to relative position embeddings. Right, so our MLP layers are now gated, we have an interesting gated MLP with like a swig-glue +1. It's like a residual connection from the gate, from the gated part to the regular MLP projection part. Depending on the model size, so we have two models. There's the GPT OSS 120B, which has 36 layers, and the 20B has 24 layers, and they all have the same residual width dimension, which is so you can choose how much depth you want. And on the bigger model, there's 128 experts, and we select 4 for every token. And on the smaller model, there's only 32 experts. So this is a smaller model in terms of number of active parameters, but you still get the same residual width. And thanks to the fact that we put the weights into low precision, so we're using MXFP4 quantization, you can fit the entire model into an H100. So we really cared so that you can use your bigger model on your bigger box. So H100 or DJX Spark if you have one, or your MacBook. So probably this one can actually fit. It looks like a Pro, so it could probably fit a GPT OSS 20B. Right. So if you go to GitHub, there is a repo called GPT OSS. It's a pretty interesting kitchen sink of all the things you might need when you're using the model. So there's multiple model definitions. Like if you're making, for example, Cerebrus implemented our model, and the way we explain what the model is by putting a very simple PyTorch definition of it, which requires like multiple GPUs and uses tensor parallelism to run experts. So it's like a very simple implementation that's correct, that we believe is correct. There's a Trident implementation, which I'm going to talk about a bit later, and a metal implementation. We also add some Python tools in a browser. Those are pretty aligned to the formats we have in the model. So to show you how to use the model, there's a terminal chat. It's pretty fun. You can add your tools, like, for example, like a self-modification tool. You can just let the model to write code to its own system prompt and then restart. And a web server. So it serves the model through the responses API. So this is a reference implementation for the API. It supports tools and everything you need to kind of take the full advantage of the model. Right, and we had to include this sub-package called GPTOSS.evals, which includes all the correct ways to condition the model to get matching performance to our benchmarks. So we really care about you reproducing the results exactly. So it's really important to get the system prompts and everything right, and to find out how to do this, you just go to GPTOSS.evals. We publish like GPQA, AMI, Human the last exam, I think there's as well. There's like a pull request for memory hanging somewhere. So, and this is everything you need to make sure your model is correct. Usually if you don't get the implementation correct, you're going to start seeing really weird behavior. For example, if you get it wrong, you might see that the model is making syntax errors when making tool calls. These are very annoying. Like there's a lot of tiny details to get the model running right, and especially since a lot of people can serve the model now, it's really important to get these benchmark scores matching. Like if you have benchmark scores matching for perplexity evals and for sampling evals, then just make sure you kind of try all of them, and once you see roughly the same numbers, then you're good. Okay. So there's an interesting bit there. There's a folder called metal, and we have an implementation of the entire model with multiple metal kernels. It's a product of Love, and it has 10,000 lines of code, so pretty much every particular important kernel that you need to run the model is there. It uses all the metal tensor core-like things, so the model runs pretty nicely, especially like a 20B on the MacBook. It's very fast. Another fun one is Trident kernels. So Trident is this language by OpenAI where you can write CUDA kernels that look like Python programs. It's a very simplified way of doing CUDA, but you can get matmls to run really fast using this language, and you can get really fast like flash attention too and things like that. So there's a secret folder in there called Trident_kernels, which contains an actual matml implementation, which uses, has an old name called matml OGS, which allows you to use MOEs. And there's an implementation for a swig-glue kernel and the top K that you're going to need to do expert routing. Right, so, and kind of Trident kernels has this feature that it takes your weights out of the network. and it puts the weights into low precision storage in your main memory. And when it fetches it into the main memory, it expands the width of the floating point number so it can perform high precision computation. So this is what enables the network to fit in an H100. Okay. I'm going to mention some fine-tuning applications now. So we released a follow-up to the model called GPTOSS Safeguard. So what we do is we train the model to condition on the policy. So you fit like a policy into, for example, content moderation. This is the type of content I don't like. And then you give it some content and it makes a decision of whether it adheres to the policy or not. It also gives a good example of if you're trying to decide how to serve the model, should I include chains of thought in the output or not. You know that if you don't want the user to actually see thinking about the policy, because the policy could have some like secret information, better not to expose the chains of thought. Right. So another one, which is before by Eric Wallace and Olivia Watkins and all of these good authors, Miles Wankach and Chris Koch, they tried this to assess what's the risk of like fine-tuning the model. Like imagine you have a malicious idea and you want to try it out. So if you apply some simple off-the-shelf methods to fine-tune the model on some bad data, how far can you push it to become unsafe? So we really to be that basically expert humans on like cyber and bio tasks are doing better than these models. So far there's no like too much of the frontier risk of releasing these capabilities to the world, which kind of enabled us as a company to share these things with you. Right. So. And I guess one important thing about GPTOSS Safeguard is that, well, it improves on these moderation tasks, and it gets really close to this internal safety reason that we have. So if you want to do content moderation, well, this is the thing you can go to, and it's another way to show that you can actually get more interesting applications out of the model. Okay. Now there has been a lot of uncertainty about how to fine-tune the model and how to make it successfully. There's like two works I want to highlight. One is doing supervised fine-tuning, and they found that if you use the learning rate and use a special conditioning for the prompt formatting, like if you use our prompts for our existing tasks and use your new prompt format for your tasks, you're not making a lot of forgetting. And another one is this SFR deep research. They just continued training RL in their amazing RL environment, and they gave like an 11-point boost on Humanity last exam. So yeah, this is what I wanted to bring up. I'm very happy to share the model with you. I'm ready to take questions. Let's have a chat. Thank you.
Yeah. Quick question. You mentioned that you enabled some tools in GPTOSS. Just how to use them? I mean, like, what do you need to set up to make it working with web browser or with code with terminal? You probably need some environment or like wrapper around the model itself to actually call these tools, right?
Right. So you have to write, like, I guess the one name of it is a harness. Kind of it maintains the loop as the model, and as soon as the model it issues a channel called commentary. And the commentary, it issues some text that describes what kind of tool it wants, depending on the context, and what are the arguments to the tool. So you have to trap, respond to this message, and then fill some formatted text that gives the model your output of the tool. So this is like the work you have to do to implement it. This GPTOSS.chat, it has a basic example of how doing this. There's an implementation for the browser and for the Python tool.
Okay, thank you.
Hey, you mentioned GPTOSS 120B fits in each one, single H100.
Yeah.
What's the context window that can you work with on that single H100?
There's some work from Unslov. I believe they fit like 81K if you want to fine tune.
Oh, okay.
Yeah.
Thanks.
Yeah. I think if you're sampling, you can do better. Yeah.
Hi, amazing talk. I have a question. So you mentioned you use sliding window attention there, right? And the context for that is 128 tokens or something. So that's like looks very similar to SSMs. Do you have like any idea how those will compare? I mean, the state space models like Mamba.
Well, attention is very simple. Like you use like only one kernel for attending to everything and attending only to part of it. So for like this model, it's like a very nice fit. We don't want to make the implementation very complicated.
Thank you.
So I think in the fine-tuning recipes, there was something about the quantization, MPX4 or something. Can you comment about this new quantization? Any motivation behind this?
Well, so NVIDIA supports this in the hardware.
Okay.
So for example, if you run this on like Grace Blackwell, the kernel executes MX54 quantized math models with like high precision accumulations. It's pretty nice to kind of use this method to quantize.
Yeah, I think at some point I was trying to get it working with VLLM, and VLLM had some issues with this quantization, but I guess it's fixed now. But yeah, I have not checked it for a while.
Yeah, it's worth to check again for sure. I know that VLM is like
Okay, it supports like VLM. Okay.
Yeah, we try really hard to get VLM to be the first correct implementation.
Okay, that's
Yeah.
good.
Yeah,
Thanks.
correctness was very important. Yeah. All right, any more questions? Yeah, there's one in the back. Yeah.
Final question.
Okay.
I was wondering why you chose to develop your own format, the Harmony format, and why you didn't go with the existing formats, like, I don't know, DeepSeek or...
Well, this is our like chat format that we designed for chat, and we decided to open source it. So kind of for us, it was the format.
Why didn't you choose existing ones? Why did you develop a new one?
Well, we did a lot of like internal testing with it, so we're kind of really confident in the format, and it's compatible with things like instruction hierarchy and things like that. So like all the prior work that we did is we really are confident in the format.
I have one question online. Did you consider adding a shared expert for the MOE experts?
And we consider, well, we chose like independent experts, and they work amazing. Yeah.
Thank you.
Yeah.
Thank you. Thank you for the amazing talk.
Yeah, thank you.
Thank you very much.